So today we have notes on the second half of chapter 13. Again, on Monday, you should have read and taken notes, but this flipped lesson will help you narrow down which stuff you need to know and which stuff you don't need to know. So let's go ahead and cruise through. These are the key concept questions. Again, doing all the vocab is really way more information than you need. Key concept questions will be a little bit better way to focus yourself. So the first question is, how salty is the ocean? Now, most of you probably at some point have gotten a mouthful of ocean water. Yeah? So the answer is, it's really salty, kind of nasty. Dehydrate you if you drink ocean water. Um, so other things that are in ocean water, a lot of it is sodium chloride, but as you can see here, sodium chloride is about 30% or so of what is in ocean water, and there are other salts as well. And so here you see 96% water. It's sodium chloride. But in one of the parts of the lab, rotating lab you'll do today, you're looking at how things float differently in the salt water. The salt water, to mix it up, it's about 35 grams per liter of salt. And I put a little plastic jar back there so you can see how much that is. But it's quite a bit. So 35 grams of salt in each liter of water. And the other things that affect the ocean water are temperature, the amount of light that can get to it, the amount of gases dissolved, which is usually oxygen dissolved in the water, and the density. And all of these things are going to affect the currents. In terms of what do you need to know for this, you don't, basically that it's more than just salt, but what we're going to talk about most importantly is what affects density. And what affects density is temperature and salinity. So those are the two things we're going to primarily focus on. And this is just kind of really for your information. This is a picture from the textbook, obviously. But again, those of us who are not as familiar with spending time in the ocean, it's really interesting. What lives in the ocean, the zones of the ocean are defined by how deep it is. You don't need to know a lot of this, but it is interesting. The surface zone of the ocean, just this very first part, that light can penetrate readily, that's where most of the life, a lot of the algae and microscopic things live there. If you've ever been scuba diving, you don't have to get very far down before all of the wavelengths of light don't penetrate well, so the colors look different. But most of those things, the coral reefs and that, are in shallow, warm layers of the ocean, depths of the ocean. Then you get deeper and deeper, and it gets not just colder and darker, but much, much denser. And it's actually very difficult to study the floor of the ocean because of the tremendous amount of pressure. It's enough pressure that it will crush things. And you've probably heard stories about submarines. If they have, a problem, they can literally be crushed and destroyed deep underwater. The very, very deep places, we send robotic things down to see it because it is just too difficult and dangerous for humans. So anyways, that's that. We're not going to spend a lot of time talking about the different types of life down there. It's interesting, but we are going to focus more on the currents, which it turns out are directly related to the density. So as you just heard in the brain pop, the currents on the Earth, and you'll notice this exact same picture is cut and pasted into your lab, and you'll need to color the arrows. Basically, we have surface currents, which are shallow, which is a couple hundred meters deep, and those are caused by winds. Also in the lab, when you're playing with a fan, I put some little toothpicks on that so you can see the waves. You can see the currents that form. You can move the rocks around and see how the continents might affect that. So those are surface currents. And those are affected by similar things to what affect weather patterns, which are caused by winds. Then, let's see, and then we have the Coriolis effect, which we'll talk about. These we'll talk about a little bit more also as we talk about weather. But basically, because the Earth is spinning, things don't travel straight north and straight south. They have a certain curve to them. So you see in the southern hemisphere, things tend to go counterclockwise. And in the northern hemisphere, things tend to go clockwise. And that's because of the spinning of the Earth. Then beyond that, so you see here we've got warm currents and cold currents. On this image, it's a little bit harder to see the cold currents. And then the Gulf Stream, again, major weather making things. And we'll talk about this a lot when we talk about currents or when we talk about climate. But you have areas like this. You've got the Gulf Stream, which is a warm current going up the coast of North America. And then over here on the west coast of North America, you've got the California current, which is a cold current. So you could pick two places that are at a similar latitude, like here in Washington State and over here on the East Coast. Where is a better place to spend time at the beach? East Coast. Because at the same latitude, at the same altitude, these warmer currents are making a tremendous difference. The depth of the ocean affects it a little bit as well, but you don't hear about a lot of people spending time in the beach in Washington State, Oregon, or Northern California because it's very cold and it's not really beach weather. Southern California is far enough south, you're getting other effects. But, so that's the general idea here. So what is causing these deeper currents and these big, so again, part of this is the wind currents. And then let's look at the other big idea, deep currents. So this is, we have two different demonstrations in our lab that are demonstrating this. So the deep currents are affected by the density, and the density is affected by a couple different things. And basically, if you imagine this, if you have, over here, you have 1 liter of water, and here you have 1 liter of salt water. So this also has 35 grams of salt and other minerals in it. For the same amount of space, this is much more dense. So if you put something in the water, here it's going to float kind of normally, and then here that same thing should float a little bit higher up. Because it's more dense, it pushes it up. And with the demonstration we have, it's actually kind of hard to see that. But if you've ever swam in like oceans, some of the hot springs, they are much easier. You float much easier than you do in a swimming pool because there's more buoyancy. There's basically more stuff pushing up on you, pushing down on you. So how does the density of the ocean change? What can change the saltiness of waters? What can change the temperature of water? Yeah, but nobody's out dumping salt into the ocean really so much. What's one thing that can change either the temperature or the saltiness? Okay, good. So the climate or the sun shining. So obviously at the equator here, the sun, you get really direct sunlight, that is going to heat up the water. As the water becomes warmer, it becomes less dense, it rises, and it moves this way, right? Yes. Yes. Yeah, so areas like the Dead Sea and the Great Salt Lake are very easy to float. Okay. So yeah, Salt Lake areas like the Dead Sea, the Great Salt Lake is very, very salty, so it's even easier to float. So here we have at the equator, it's heating up the water so it gets warmer, and obviously the North Pole or the South Pole is very cold, and so it's colder, it gets denser. Now, that's one thing that's going to create this current, and we have a demonstration of that in part 4. The other thing that happens is that when water freezes, only the fresh water freezes. So icebergs, they are only fresh water. The salt stays behind. Similarly, when water evaporates, only the water evaporates and leaves the salt behind. So yeah, let's go back a minute here. So temperature, that's easy. The sun heats it, particularly at the equator, and warmer equals less dense. But salinity, when ice freezes, it leaves the salt behind. So that's going to make it saltier. And when water evaporates, it's going to make the water saltier. But what's going to happen here, so the surface currents have carried the water towards the poles, that's colder, and as the water cools, the ice forms and makes the water even more salty. And so then this gets dense, and then this sinks. And so all this is creating these global deep currents. Now, this does a couple of things. One of the very interesting things is it keeps the water in our oceans constantly circulating. And as I mentioned in Brain Pop, it might take hundreds or 1,000 years for the water to totally overturn or circulate. But this, for life, for water, for minerals, for all these things, it's not stagnant. It's not staying in one layer. It's constantly moving, although quite slowly. And so this is going to contribute to the currents. All right. And other things this causes on a smaller scale, that's kind of on a global scale, um, these currents and this changing in the density can cause things, it causes nutrients, it causes this thing called upwelling, which is basically the nutrients and sediments from the bottom getting pushed upwards. And that provides food for fish. And it's a seasonal thing, it can be a seasonal thing, and so then it affects fishing and schools of fish and us eating fish, like anchovies. Let's see. Okay, and so now we're just gonna move on to back onto our activity. There are 4 different parts, and I will leave this here. This is also in the textbook. You can use this for that other section.